We are getting our screen set and we are ready to go. We're going to be talking about rules of exponents today. The first rules of exponents we're talking about are power of a power. You'll notice that we have a chart here where we have one column that is going to have multiple problems, one column for a long version, the shortcut that you'll be able to take as soon as you see it, and then a column for all of your answers. So let's get started. We have the power 5 squared, or 5 to the second power, all to the third power. So what this is telling us is that we want to do 5 to the second and multiply it by itself 3 times. The long version would look like this. 5 to the second multiplied by 5 to the second, which is also multiplied by 5 to the second. Well, how many times are we multiplying 5 by itself? 1, 2, 3, 4, 5, 6. So the shortcut version, if we come over here, what we can do is, if you notice, we multiplied 5 by 5 by 5 6 times. We also notice that 2 times 3 is 6. So the shortcut version is you're going to take the power and that and multiply them together. So our answer is going to be 5 to the 6th power. And typically you're going to write these in exponential form, so leaving the base and the exponential form. So let's try another one. This one's similar, but a little bit different in the sense that you have a variable to a power. So n to the third, all to the 4th power, which tells me that we're going to do n times n times n, and we're going to multiply it by itself 4 different times. Here's our long version. N times n times n, n times n times n, n times n times n, and n times n times n. Now, how many times do we multiply n by itself? 3, 6, 9, 12 times. And again, our shortcut here tells us that we can take the base and multiply those 2 powers, and you get n to the 12th. And that's why you can do the shortcut, because we are multiplying n by itself 12 different times. The next one is a little bit different. Now I have a coefficient, a variable to an exponent, and then to a power here. I want you to recognize that the 5, our coefficient, is going to the power of 3. And our x squared is going to a power of 3. But the 5 is not going to the exponent of 2. So the long version here, we're going to go 5 to the 3rd power, 5 times 5 times 5. Then we're going to go x squared to the 3rd power, x times x, x times x, x times x. So what that's going to get us is 5 to the 3rd, x to the 2 times 3, which would get us, now we're going to work this one out because it is a coefficient, 125 x to the 6th, because 5 times 5 times 5 is 125. What I want you to do right now is pause the computer and try and figure out what the answer to this last one is going to be. I added in multiple variables, different exponents. Let's see if you can get it. Okay, now that you're back, the long version, I'm not even going to write the long version out here. The shortcut version would be 5 to the 2nd power, and then x to the 4th to the 2nd, v to the 5th to the 2nd, and n to the 7th to the 2nd, because we're taking them all. So it looks like this. Now from here, 5 to the 2nd is going to be 25. X to the 4 times 2 is 8. V to the 5 times 2 is 10. N to the 7 times 2 is 14. I hope you got that right. So let's talk about a rule, because there's always a rule. When given a power of a power, you want to multiply the exponents together and keep the base. So that is your power of a power rule when you are multiplying or using exponents. I hope you found this useful, and you can use these examples moving forward. Have a good day.